Assalamu alaikum wa rahmatullahi wa barakatuhu. How are you all, student? Hope you all will be fine and doing well for your studies. So, your student welcome you all for our chemistry lecture, that is modern periodic table. This is our 10th lecture for the same. Today, student, we are going to study periodic trends in elemental properties in the modern periodic table. What do you mean by periodic? The one which is repeating at a regular interval of time and space. Fine. The one which is repeating with a regular interval of time and space means periodic. As we know, the original structure of the modern periodic table was based on empirically observed periodicity in the elemental properties. Thus, the properties of the elements is periodically repeated. Okay. Thus, elemental properties show similarity in a group and show gradual variation across a period. The elemental properties of the elements in a group is similar, while across the period it shows gradual variation. The quantum mechanical model of atom explains the observed periodic trends of elemental properties. So here student, we will now discuss in this section the periodic trends in some physical and chemical properties of element, relating them with electronic configuration and the nuclear charge. You are very much familiar with the term electronic configuration. While nuclear charge means the charge of an element in an atom in a nucleus. As we know, in a nucleus, neutron and proton is present. As proton carries positive charge and neutron carries no charge, it is neutral. So, overall the charge on the nucleus is positive. Hence, these trends are explained in terms of two fundamental factors, namely attraction of extranuclear electron towards the nucleus. What is the attraction between the nucleus and the electron, as well as repulsion between electrons belonging to the same atom. As we know, opposite charge attract each other, so there is an attraction between positive and negative, and repulsion between electrons, that is between negative and negative. So here these attractive and repulsive forces operate simultaneously in an atom, distinct with opposite forces, that is a positive and negative, that is a attraction and repulsion forces operate simultaneously in an atom. This result in two interrelated phenomena, which is known as effective nuclear charge and screening effect. So here student, today we are going to study effective nuclear charge and screening effect. What do you mean by effective nuclear charge and screening effect? In a multi-electron atom. What do you mean by multi-electron atom? An element in which more numbers of electrons are present. The positively charged nucleus attract the negatively charged electron around it. So here there arises attraction between positive nucleus and negative electron. So here attraction forces occur. as well as there is mutual repulsion among the negatively charged extranuclear electron. As there is a attraction forces, there is repulsion forces. There is attraction forces between nucleus and electron, between positive and negative, and there is a repulsion forces between the negative charge. So here the repulsion by intershell electron is partially important. Where there is attraction force important, there is also repulsion force important. This results in pushing the outer shell electron further away from the nucleus. As we know, there are number of shells present in an atom. The electron which is present in the first shell will be nearer to the nucleus, fine, while the electron which is present in the second shell will be further away from the nucleus as compared to the first shell. Okay, as we move from first shell to the second to the third to the fourth, fifth, sixth, and so on, the distance from the nucleus to the outermost shell is increasing. So here first shell is more nearer to the nucleus than the second, and so, which in turn more nearer to the third, and so on. We are doing an experiment. Take a magnet. Okay, keep iron filling in a row. The iron filling which is nearer to the magnet will having a more force of attraction than the one which is further away. Similarly, here also the electron which is present in the nearer shell will be having more force of attraction as compared to the outer shell. So here what is happening? The inner shell is pushing the outer shell electrons further away from the nucleus. So the outer shell electrons are thus held less tightly by the nucleus. So here the attraction forces between the nucleus and the outer shell is less. So they are less tightly held by the nucleus. In other words, the attraction of the nucleus for an outer electron is partially cancelled. Here also, as the shell is been increasing, the attraction of nucleus and the outer electron will be cancelled. It means that an outer shell electron does not experience the actual positive charge present on the nucleus. Means the attraction forces between the nucleus, that is a positive charge, and the outer shell electron, that is a negative charge, will be cancelled. They will not experience the attraction between the positive and the negative. So here the net nuclear charge actually experienced by an electron is called the effective nuclear charge. Net means total. Total nuclear charge which is experienced by an electron. The total negative charge, the total nuclear charge, that is a positive charge which is being experienced by an electron, is called the effective nuclear charge. So here the effective nuclear charge is lower than the actual nuclear charge. Obviously it will be lower than the actual nuclear charge. In other words, the inner electron shield the outer electron from the nucleus to a certain extent. What do you mean by shield? Everyone is today is operating mobile. We are having a screen on it. Okay, it is protecting. It is a layer between you and the mobile. Okay, so like this way, the inner electron, they act as a shield between the nucleus and the outer electron. So this effect of the inner electron on the outer electron is called screening effect or shielding effect. Fine. Which effect? When the inner electron will act as a shield between the nucleus and the outer electron. So that is known as screening effect or shielding effect. So here student, effective nuclear charge is being denoted by the symbol ZeFF. Fine. So effective nuclear charge will be equal to Z minus electron shielding. Electron shielding is being denoted by a symbol sigma. Fine. So effective nuclear charge formula is equal to Z minus electron shielding. That is Z minus sigma. Sigma is nothing but your shielding constant or screening constant. And this value of sigma will depends upon the type of the orbital, which orbital that the electron occupies. Fine. The value of sigma will depends upon type of the orbital that an electron occupies. So this is the formula for effective nuclear charge, that is Z minus sigma. As we move in the periodic table across the period, actually nuclear charge is increasing by 1 at a time. Why? Because the atomic number is been increasing by 1. As we move, see the periodic table, modern periodic table, as we move in the period, in any of the period, in the first, second, third, any of the period, the atomic number is increasing by how much value? It is increasing by 1. So here nuclear charge will also be in increases by 1. The newly electron will be added. So as we move, then one from atomic number 3 to 4, one electron is being added. Okay, so the valence shell remain the same. The valence shell will remain the same. In the third period, the number of shell in any of the element will be 3. In the fifth period, how many elements are present? The number of shell will be 5. So the valence shell will remain the same. The newly added electron will accommodate in the same shell. As we are moving across the period, valence shell will be remain same. Fine, but the newly electron will be added in the same shell. So there is no addition of electron to the core. Thus, shielding due to core electron remain the same. Fine, shielding due to the core electron will remain the same to the actual nuclear charge increases. Here the shielding will be same, whereas as the atomic number is increasing, its nuclear charge is increasing, so its nuclear charge across the period will be increasing. Thus the net result is that the effective nuclear charge goes on increasing across a period. As we are moving across a period, what is happening? Just pay attention over here, student. Think over it. As we are moving across the period, what is happening? Atomic number is increases by 1. As atomic number is increasing by 1, its nuclear charge will also be increasing by 1. But the valence shell will remain the same. So here, the newly added electron will accommodate in the same shell. It will accommodate in the same shell. Thus, shielding due to the core electron remain the same. Fine, the shielding will remain the same. As nuclear charge is increasing, valence shell will remain the same. The net result is that effective nuclear charge goes on increasing across the period. On the other hand, this is happening across the period. Across the period, what is happening, student? Yes, your valence shell will remain the same. Nuclear charge is increasing by 1. So, your effective nuclear charge will also be increasing. On the other hand, your effective nuclear charge decreases down the group. Why? Here also atomic number is increasing. Nuclear charge is increasing. But as we move down the group, from groups, as we see group 1, The element which belongs to first period will having one number of valence shell. The elements which belong to second period, it will containing two number of valence shell. So as we move down a group, a new larger valence shell is added. So here in first group elements, first period containing one valence shell, second elements, that is your first group second element, second period will containing two valence shell, so on. As a result, there is an addition shell in the core. New and new shell has been increasing. Fine. The shielding effect of the increased number of core electron outweigh the effect of the increased nuclear charge. See here, the shielding effect will play a role. It will affect the increased nuclear charge, and therefore the effective nuclear charge fell by the outer electron decreases larger down a group. So your student, down the group atomic number is increasing, electron nuclear charge is also increasing, electron is added, but here valence shell is also being added. As additional valence shell is been adding, shielding effect will play a role and it will affect the increased nuclear charge, and therefore effective nuclear charge fell by the outer electron decreases largely down a group. Effective nuclear charge is being increasing across the period while it is being decreasing down the group. Hope you all have understood it well. We are moving further towards periodic trends in physical properties. There are various physical properties of elements such as melting point, boiling point, density. All of them shows periodicity. In this section, we are going to consider some of the periodic trends in physical properties such as atomic radii, ionic radii, ionization enthalpy, electron gain enthalpy, and electronegativity. Inshallah, in our next lecture, we are going to study these properties and what is it periodic trends in the modern periodic table. Which properties? Atomic radii, ionic radii, ionization enthalpy, electron gain enthalpy, electronegativity. Hope you all have understood what is effective nuclear charge, what is shielding effect, what is happening across the period, what is happening down the group. Fine. Across the period, effective nuclear charge is increasing while down the group effective nuclear charge is being decreased. Take care students, study well. If you are having any problem, let us sort it out, let me know, and inshallah we will sort it out. Till then, take care, study well, do your best. Thank you students.